Hello dear students. Today we are going to discuss one more very important concept for all the competitive exam, that is molecular orbital theory. From this theory also at least one or two questions will come. With the help of molecular orbital theory, mainly we can able to identify bond order of the molecule, stability, bond length and magnetic character of the molecules. Just you need to know two things, that is up to 14 electron system and above 14 electron system. See, if you take any molecule like nitrogen, nitrogen can combine with another nitrogen and become N2. So in this theory, mainly we have to take the total electrons in the atom, which means complete atomic number of two nitrogen atoms we have to take. Like first, in atomic number of nitrogen is 7 and here also 7. Total we get 14 electrons. See here there is a order. This order arranged based on the energy. So in this order, the orbitals are arranged from lower energy state to higher energy state. The lower energy state is 1s, higher energy state is sigma star 2pz. And there are some orbitals which are having same energy, like pi 2px equals to pi 2py and pi star 2px equals to pi star 2py. Just you need to understand star means what, without star means what. So the orbitals which are indicated without star is nothing but bonding molecular orbitals. Bonding molecular orbital. The one which is star considered as anti-bonding molecular orbital. Then we'll directly discuss about applications of this theory. Just we are talking about nitrogen molecule. So it is formed with 14 electrons. Just those 14 electrons have to fill in this order, these orbitals. For every orbital, maximum we can able to fill 2 electrons. So 2 and 2 and 2 and 2. Suppose if the orbitals are having same energy, just we need to fill one first. If still electrons are available, then you have to pair those filled electrons. So that since we have more than the required electrons here, so just directly I am filling like 2 and 2. So we have filled 1, 2, 3, 4, 5, 6. 6 to the 12 electrons. Just 2 more electrons are there. Those 2 electrons I am filling here. So total we filled 14 electrons. So after filling this, we can able to understand all these applications. The first application is about bond order. So bond order is nothing but the number of bonds present between the atoms of molecule. There is a formula for bond order and there is one more shortcut also to find bond order. Just both things we'll discuss here. So bond order is nothing but, or bond order is equals to total number of bonding electrons, number of bonding electrons minus number of anti-bonding electrons divided by 2. Divided by 2. Just try to understand this. Number of bonding electrons minus number of anti-bonding electrons by 2. With this we can able to define bond order. Just same thing I will tell you. See, I already told you the orbital whichever is with star is called anti-bonding molecular orbital. Those electrons are called anti-bonding molecular electrons. So this is bonding orbital electrons and these are anti-bonding electron orbitals. Just we can able to use those things. number of bonding electrons. Just we can able to count 1, 2, 3, 4, 5. Total how many? 10 electrons. So minus. So number of anti-bonding electrons, just 2, 1 and 2. 2 means 4 electrons, 2 into 2 by 2. So we can able to get, that is 6 by 2, which is equals to 3. So the bond order for nitrogen molecule is 3, which means nitrogen and nitrogen can combine with triple bond like this. This is the first application of bond order. So this is one way to define bond order, and there is one more shortcut to find bond order. That is very simple. Just we can see number of electrons versus bond order. It is most easiest way. This we can able to use to solve questions in competitive exams. So that is 14 electrons. Wherever you can get 14 electrons, that bond order will be always 3. And if the electron number is less than 1 from 14 or more than 1 from 14, will be 2.5 bond order, which means 13 electrons or 15 electrons. The bond order will be 2.5. And similarly, 12 electrons or 16 electrons, bond order will be 2. And 11 electrons and 17 electrons, bond order will be 1.5. And 10 electrons and 18 electrons, bond order will be 1. So this is how we can able to find bond order. Suppose if the molecule contain more than one atom, for those molecules we can able to find bond order with respect to resonance. That we are going to teach in the later classes. Hope it is clear about bond order. And we are going to discuss second application, that is stability of the molecule. See here, stability, just in simplest way we can able to find out. There will be 3 conditions under stability. The first condition is bonding molecular electrons whenever it is equals to anti-bonding molecular electrons. Molecular electrons, then the molecule doesn't exist. The molecule doesn't exist. Examples: He2 and Ne2. We already know that helium neon belongs to 18th group. So those are very inert. So there will be in monoatomic gas form, not in diatomic gas form. That's the reason these two molecules will not exist. For these molecules, number of bonding electrons will always equals to number of anti-bonding electrons. Coming to case number 2, so that is bonding molecular electrons. If it is greater than anti-bonding molecular electrons, so the molecule is more stable. Basically, the bonding molecular electrons are orbitals having less energy comparatively anti-bonding molecular orbitals. That's the reason the molecule become much more stable. Like N2O2, all those are the examples for the second category. And coming to third or application 3, so bonding molecular electrons will be lesser than anti-bonding molecular electrons. then molecule will be very, very unstable. So this is how we can able to study of stability of the complex. And coming to third application is, that is magnetic character of the molecule. See, magnetic character can be means magnetic character mainly segregated into two types. Those are paramagnetic substance and diamagnetic substance. So paramagnetic substance when we will get, and diamagnetic substance when we will get, we can discuss that. It's very simple. See, to find paramagnetic and diamagnetic, compulsory you have to know this application. Means this order you supposed to know. If you don't know this order, you can't able to find out magnetic character of the compound or molecule. So let us take this. See, we are filling electrons in this order. After filling electrons in this order, if any orbital having unpaired electron, those molecules comes under paramagnetic in nature. Suppose after filling electrons in this orbital diagram, if everywhere 2 electrons only present, those molecules comes under diamagnetic in nature. Just paramagnetic in nature is nothing but unpaired electrons supposed to be in the energy diagram, and if all are paired, then we can able to say the molecule is having diamagnetic in nature. So that is how we can able to conclude magnetic character of any molecule. And here some as some things you have to remember. So magnetic character doesn't depends on either even or odd number of electrons. Means electrons doesn't decide any of the property. Some may think that even number of electrons having diamagnetic, odd number of electrons having paramagnetic. That logic is completely wrong. You should not think like that. Hope it is clear. And just one point I want to say, that is, if you take any C2 molecule, so in this case, the bond order you will get, bond order is 2. Those 2 bonds are 5 bonds only. So that is about an exception point. Hope it is clear. This is how we can able to find out bond order, stability, magnetic character. And just one more point I want to say, bond order is directly proportional to bond strength which is inversely proportional to energy or reactivity and which is also inversely proportional to bond length, very important point, and which is directly proportional to stability. Yes, students. Yeah, so one question based on the above things. Find the bond order for these molecules or ions. Just N2, N2 plus, N2 plus 2 and NO2 minus 2. Write the bond order for these ions. Thank you. There is one more point here. For above 14 electrons, there is simple difference in the order, that just I will write it. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, pi 2py, and sigma star, sorry, pi star 2px, pi star 2py, and sigma star 2pz. There is a simple remembering from the basic 14 electron rule. Just in case of 14 electron rule, this will be located between two pi orbitals. Now just we are keeping that sigma 2pz before pi orbitals. Thank you.